In this tutorial, we'll build a parametric capsule, wrap it in a mesh, run a study fluent solve, pull out drag and volume, then compare multiple designs to find the best shape. Also, full transparency, I used AI to teach myself and got guided through each step of this workflow. And you can do the same to teach yourself CFD for free. First, open ANSYS Workbench. Then select Fluent, drag and drop. Right-click on Geometry and select Design Modeler. Select the plane you want to sketch on. Sketch the half profile for the 3D shape you'll be optimizing. You can copy this design. In my case, I'm using an arc by 3 points for the nose, a vertical line for the body, and another arc by 3 points for the tail. Since this is a parametric sketch, it's important to add constraints. This will help ANSYS vary the geometry the way we want it. Next, we move on to adding the smart dimension. Then one really important step here is to press the checkbox and rename this. Do this for all the features you want to parameterize. So here I'm adding tail length, nose length, radius, and total length. Then we move on to making the sketch 3D by using the revolve feature. Click on revolve at the top, select the sketch from the tree, select the sketch for geometry, vertical axis to revolve around. Make sure to hit generate every time you change something to see the update. Next, click tools, add an enclosure, and make it cylindrical. Then adjust the dimensions to make the enclosure sufficiently big enough. Next, go to create, add boolean, change it to subtract, go to the tree, the drop down, and select the two bodies. Make sure to select yes for preserve bodies. Then go to create, go to body transformations, select translate, select the body inside, and we'll be using this to measure the volume. So move it away from the enclosure. And now to view the parametric body, click on parameters at the top, and now you can update these values to make new shapes. But we'll later automate the process with ANSYS. Now save and close this and move on to meshing. Right click, edit. Now in meshing, go to the left panel, click on mesh. You can ask AI for help here with the settings. I'm going to go to quality and set smoothing to high. One important setting here is the element size at the very top. You can change this to change the quality of your mesh. You decrease the value to increase the quality. And there's a limit to this on the student version, on the number of cells you can have in a mesh. Hit generate to see the changes you make, and you can look at the quality of your mesh. Next, we want to work on adding the named selections. Click on the top face and press N. That will pull up this menu, and you can make the top face the inlet, the bottom face will be the outlet, surrounding wall will be the wall, and the body outside will be the body for volume. Then you want to zoom in, change the selection mode to box select, select the faces inside, and that will be the capsule, the shape you are optimizing. Then go back to Workbench, zoom in on mesh, right click, hit update, and make sure the green tick mark appears on the right. After that, right click on setup and click edit. On the pop-up menu, hit double precision, select around 4 to 8 processors, but this is limited on the student version to 4. You can copy these settings as they are, and you can ask AI for help with changing them as per your needs. I'm choosing K omega. For the turbulence model, in materials, go to fluid, right click on air and hit edit. You're going to change this to water, so go to fluid database, scroll all the way down to the bottom and find H2O liquid, hit copy, close, and in the drop down select water, hit change create and close. Now the fluid won't be changed there until you change it in the cell zones. Right click on fluid in cell zone conditions, change the material name to water, hit apply and close. Now if you want, you can go back to fluid and right click on air and delete. Now go to boundary conditions And here you can see ANSYS has already sorted all the name selections into the sections. Depending on how you named your selections, ANSYS will sort them. So right click on inlet, hit edit. You can copy the settings here as well. I'm making the inlet pressure 1 meter per second. You can change the other settings like for turbulence if you'd like. Apply and close. Now go to outlet. In outlet, you just want to make sure the gauge pressure is 0. Hit apply and close. You can do the same thing for walls. Make sure it's no slip and stationary wall. Hit apply and close. Next, go down to methods. Double click. Make sure it's least squares base. Choose scheme as simple. All second order. Then double click on report definitions. Click new. Volume report. Volume. Choose the solid. Make sure it's volume at the top and hit OK. Make another one. Click new. This time force, drag. Make sure the top is drag force and select the capsule. Hit OK. And if you'd like, you can rename these to volume and drag respectively. One more important thing is to make sure your vectors are aligned. So look at the vertical axis along which the flow is moving, and you're gonna write the flow vectors accordingly. So in my case, it was along the negative z direction. And hit OK. This is only for forces, doesn't apply to volume. Then in initialization, make sure you're on hybrid, and you can hit initialize. Then go to run calculations, change the number of iterations. The higher iteration number, the longer it will take. Sometimes it might converge earlier if it finds a solution. You can look at the graph and see how drag and volume change. Volume is obviously constant. And you can right click on the report definitions and hit compute and view the values. Now come back to Workbench and make sure all of these are green text. And if you'd like, you can view your results. In results, go to the top, click on streamline, hit OK, add inlet, hit apply, and you can visualize the streamlines. Then if you want, you can add pressure contours, hit OK, change the location, hit apply, and you can look at how the pressure behaves. If you want to add some details, you can increase the number of points on the streamline, and you can visually study this or compare between the designs. Now to optimize it, go to Workbench, drag in a response surface, open parameter set first, and you'll notice the output parameters aren't here yet. So go back to Workbench, open setup by double clicking, go down to report definitions again, right click, edit, and enable create output parameter. Hit OK. Do the same for volume. Now when you open parameter set again, it should show you the output parameters. Now in Workbench, we can edit the design of experiments. Right click and edit. And if it doesn't seem right, just hit refresh at the top, it'll update. And now you should see all your parameters here. And you can customize the range. Then click on design of experiments at the top in the left panel and change it to optimal phase filing design. Change it to user defined samples, and here you can add your custom number of designs you want to test. Then go to the top and hit preview, and that will generate all the design points, all the designs that will be tested for your geometry. And then hit update, and that will actually run the simulation for all the designs. And this can take really long depending on how refined your mesh is and how many iterations you put in your setup. Once you're done with this, you're done with majority of the work, and now you can just look at all the generated designs. You can look at all the graphs ANSYS makes, and if you like, you can go back to project, right click on response surface, hit update. Now open response surface and you can see all these graphs. You can look at how sensitive each parameter was to your output, and there's a lot of different graph ANSYS generates to help you analyze. And you can also look at the minimum and maximum values. You can see the maximum of each parameter and the minimum of each parameter and the inputs that created that output. And these are the predicted values from the response surface. So you can consider these to be possible optimal values, and you would have to copy these inputs and verify the results. To do that, you can right click on any of these values and hit insert as design point. Then go to the parameter set, right click on the inserted point and say copy inputs to current. That will update the current values in the table, and you can go back to your workbench and update the entire module. Then you can view this result. Double click on result. And now you can see the new shape. This is definitely not the shape we created at the start, and it's got different pressure controls and streamline. Now you can also view the other designs that the response surface suggested. Add it as a design point, copy to current, update the module, and this is the other shape.